you said in the introduction, I do a lot of work in transportation technology, but it's not often you get to sort of step back and talk about the big picture, kind of the fun and what's coming and sort of what it all means. As I go through this, if you've got questions or thoughts, I hope we can kind of keep a conversation. We've got a nice intimate group here and interested in your take on things. But, kind of, when you talk about transportation technology and, think of big ideas and looking into the future, there's all kinds of fun things. It's kind of a neat thing to go back in history and look at what's been proposed and sort of fanciful looks at what might be there if you're sort of starting from scratch or having appears to be monorails and bike tunnels floating in midair. It's fun to do that, and there have been lots of projections, and of course most of them have not panned out quite yet. Still waiting for this one, flying car. That would certainly help get to the office back and forth. But a lot of what's really happening in technology is much more gradual, and sometimes it kind of sneaks up on us. But the changes it's bringing to the transportation system are no less profound or kind of gee whiz of some of these things. So, we don't have this car, but we got this car. Anybody know what that is? Yeah, it's the Google self-driving car. Anybody know? It was recently in the news. Anybody know why it was talked about the last couple of weeks? It's kind of on the street in the urban environment here. They took it around Mountain View, California. When Google had been developing this car, they were on mostly rural California highways, not many things to hit. But they've started to use the car in traffic, where people say there's maybe 100 times more stimuli in an urban environment than a freeway environment, and you're dealing with pedestrians and crossing guards and railroad tracks and all kinds of different things. And so the technology's advanced to that point where it's being piloted here, and maybe someday we'll all be clicking on the autopilot and letting it drive us home. So it's a Lexus. It's not a bad car there, but it's not the flying car. But still, there's these profound changes that are taking place, and it's really interesting when your responsibilities involve planning for the future of transportation and a long term, like the folks here at Compass and many others in the Valley, and beyond that, many others who are interested in the futures of their community. How do you deal with this kind of a thing? So, part of the context, of course, is there's this digital revolution in society. So, we're all aware of it. I'm sure most of you've got a smartphone or a tablet or these kind of connections. You may have internet services in your car. These things are sort of slowly creeping into our world, and they're causing profound changes in what's possible. And a lot of things are sort of happening in transportation that are sort of a result of these broader trends, and it's really people finding creative ways to apply these big ideas of cloud computing and massive data crunching ability and internets and sensors that are inexpensive that could be deployed on all kinds of objects, and then objects can be tracked. And so it's kind of a bit of a Wild West world in transportation, and it's really changing what we need to think about when we think about what the realm of transportation solutions are. So part of my background is I'm a civil engineer by training, and the conventional thing is if you're planning for traffic, you kind of figure out what the traffic demand is, and then you go to some manual and you look up and you see how many lanes do I need, and you build a road that wide, and if traffic grows, you add a lane, you do that kind of thing. And the sort of concrete and asphalt approaches to transportation are certainly still there. They're in some ways they're as pressing as ever because a lot of our infrastructure that we built once upon a time is in need of reinvestment. But there are a lot of other things that are on the table when you're thinking about transportation policy and transportation strategies. So when I think about the cloud computing and social media and all these things, I kind of think of the tsunami of technology. And there are things that are, I think, just going to happen to us, and we're all going to be caught off guard. We didn't see the impact of Google coming down the line or what it's now doing with devices. We didn't see the power of digital media, and everybody who dealt with selling records and tapes and things like that, CDs, got caught off guard by that. And there's just these profound disruptive technologies, and they're out there. I think we're in the middle of a period where a lot of that's going on in society, and we just have to recognize that and roll with it some way. But you can't ask sort of how all this is changing transportation, and what I wanted to do is spend a bit of time reflecting on some of the things that are happening as a result of these broader changes in transportation, and the kinds of things we're starting to see. And try to highlight some of the ways they're changing some of the basic assumptions about how you plan transportation and how you think about what the transportation system is. So if you say, what is all this technology doing to transportation? It's creating a lot of new things, many dimensions. There are new definitions of infrastructure, what transportation infrastructure means. I'll talk about that in a little bit. There are new services being offered by private companies, by startups in Silicon Valley that never existed before. There are new partnerships between public agencies that never existed before to meet some transportation need. There certainly are new expectations of the traveling public and general citizens, because we're seeing more information, more services, more things at our fingertips, and that expectation extends to transportation. So the customers of the transportation system really reset the bar for them. And certainly new possibilities, and we're only beginning to explore these. And of course, the challenge of all this, and what makes it kind of a fun field of transportation, is trying to anticipate and apply these solutions to fulfill these possibilities when there really isn't a lot to go on sometimes. So I'm going to go through a couple things. I'll make some observations and show some examples of just kind of what's going on if you look nationally, globally in transportation. And the first point is that information infrastructure has really become an integral part of the transportation system. So, again, what transportation system infrastructure used to be was a bridge, a tunnel, a road, a bus. But things about moving bits and information is much more important. And so I'm sure as you've noticed, if you've driven around the Treasure Valley or many other places, there's infrastructure out there on the roadways for about the past close to 20 years now. Public agencies have been investing in so-called intelligent transportation systems technology. So when you see the electronic signs, traffic cameras, a lot of what you don't see in traffic signal cabinets, that's made them a lot smarter than they ever were before. These represent investments in their new forays of agencies in the past few decades into using technology applied to transportation and taking a more active role in managing the transportation system. Now, a lot of this started, in kind of the early 90s or the end of the Cold War period, and you had a lot of, I think, interest in civilian investment in new high technology. And you used to build guided missiles, and now you're looking for a new market. And so there was a big push in transportation from the federal perspective that really got a boost to this kind of technology. And things started as pilot projects and demonstrations, and there were grant programs to show that, we can actively manage the transportation system. And now it's become a little more established. I wouldn't say it's taken for granted, but there's certainly a lot of progress being made, and the drive anywhere around the Treasure Valley will give you some evidence of how, at the agency level, this kind of technology is pretty common. I just want to give an example from transit, because you see buses running around the city, and it's a bus, right? How much could it have changed? It looks like what Jackie Gleason drove, right? But if you kind of look a little closer and you look at what some of the folks in this very building, this very floor, are worried about in terms of investment and decisions and management. You've got the sign in the station, I think I got a pointer, giving electronic information of when the bus is coming, when it's arriving, if there's status changes to the service. That's something, Jackie Gleason never worried about. You have the bus being tracked by GPS, and the GPS itself is tied to a back-end system where the transit managers are looking at the buses and whether they're on schedule, on performance, and giving updates to passengers, maybe making service corrections as a response to that. Odds are probably passenger counters using an infrared screen or a laser line you walk through that count the passengers that are coming onto the bus. Which is very useful in knowing, when you combine with the GPS, knowing where the passengers are getting on and off the vehicle. That has great planning application, and you can say, well, am I providing transit service to the right place, and how can I understand the levels of patronage and make the system better? There's a human interface for sure. You have the driver who's adapting to new technologies. It's changing their job, their way of interacting with the system, and how they can help to keep the system on time. Fare collection in a lot of cities involves things well beyond cash. In fact, the city of Seattle contemplated in some of their recent planning whether they are at the point where they could completely do away with cash on the buses. So I think the answer was, we're getting close, not quite yet. But you're looking at electronic payment systems, smart cards, payment by new near-field communications technology on phones, a lot of other things that are changing how you make payments. And then the bus itself might be communicating with the traffic signal system. So this is being deployed in Boise on the State Street corridor. It's used in a lot of other places as well. And basically it's an interaction between the bus and its position and its schedule, and the logic of the bus is saying, am I early, am I late? And if it's late and meets certain conditions, it can talk to the traffic signal and say, traffic signal, can I please get a green light because I'm falling behind schedule? Similar technology used around the valley and in most other metro areas for emergency vehicles. It's much more of a, it's not an asking, it's a telling. It says, I'm a fire truck and I'm coming down the highway, turn the signal green. And sometimes you'll see a little turret on top of the traffic signal that does that. So all these things are going on, and you know, there's security elements. You know, most public transit agencies have had onboard surveillance for maybe 5 or 10 years. Increasingly, those are using wireless technology that allows communications with emergency responders. So if you had a bus hijacking or a medical situation, you could get real-time video into the bus and know what's going on. And then, of course, you've got the passenger. And this is where some of the real revolutionary stuff is going on. Because remember, I talked about the agency investments in that fixed infrastructure. Most of what's been happening is actually happening with the consumer. It's the mobile device. It's through services that the end customer is using. So the passenger could be looking at their phone, and instead of just relying on the fixed infrastructure sign there in the station, they can be in their office or walking down the street or searching on Google and find information on the status of their bus. And you know, sometimes this stuff is hiding in plain sight. Just, you know, even in old infrastructure, here's the Broadway Bridge. You know, it's got conduits hanging off the side of it, which are very important communications links. So not only are we literally providing a bridge for information across the river, it's also an important part of the infrastructure that's helping to tie together agencies and provide communications for traffic surveillance and all these services that are going on. So part of the challenge of talking about technology is often we focus on the technology, the widget itself. But what the widget is really doing is it's enabling some new service or some new approach to managing the infrastructure. And so what we're seeing when we really see technology innovation in transportation is that somebody's figured out a way to actively manage transportation, to actively communicate information in real time to a customer. And so the technology allows you to do that, but there's a broader purpose behind it. And sometimes understanding that broader purpose and building relationships that help you to deliver that purpose and having policies that support that purpose is the hardest part of doing any of these things. So again, lots of examples are in place in the Treasure Valley, and there are visions to expand these more. You know, so incident management, this is one of the early applications of all that ITS technology where, you know, if there's a crash, you want to give people information in advance of that. Maybe you do it through these signs. Today there are lots of services that will do it through your phone. And the transportation goal is trying to reduce the delay, reduce the congestion, reduce the emissions from cars idling in traffic, and improve response times to clear the incident and get the system back running. Of course, in this case, you know, there's some construction going on there, so, you know, if I'm checking traffic conditions and maybe I'm choosing whether I take the freeway or the arterial, I can now, of course, look at my phone, and through the combination of information that's coming from ITD managing the freeway and maybe ACHD or local municipality managing the arterial, I can make some comparisons and make some informed judgments about which way to go. On the integrated freeway arterial, certainly an opportunity in the Treasure Valley is to think of the network more seamlessly and to tie together the infrastructure that's in place and enact plans to make the systems work better. So again, this is largely using old technology. This is, you know, investment that started in the Valley 20 years ago, but it's the purposing of it that's making power. We don't actually have to invest that much in technology. What we need to invest in is the relationships and the plans to make it all work. If anybody's been in Seattle or maybe the M1 in London, there's a lot of places in Europe, you may have seen this kind of arrangement. It's called active traffic management, and it's just getting started in the United States, but it's a way of looking at lanes of traffic, and if you have incidents or you have slowing, that you actually are changing the speed limit. That's what those signs are doing in real time. So you know, if I have maybe a crash on the right side and some lanes are closed, I might have some arrows or some X's indicating these are closed, and I I tell people, there's an accident where you left, and these lucky guys over here in the HOV lane, are unaffected. They're still going full speed. So the idea is, you're taking the intelligence, the awareness you have of what's going on in the network, and you're kind of slowing people down. And it may seem kind of obvious. If I see brake lights, I don't need a sign telling me to slow down. But in reality, a lot of congestion from these kinds of incidents is caused when someone else rear ends the back of the queue, and so it causes another incident, and it just kind of cascades. So this is an attempt to be a little smart about that. Now these are all examples of kind of agency-led, big infrastructure investment kinds of technology, relatively speaking. Another one is for transit management, and this is a fixed sign. It's kind of like what I showed with the bus, where the bus can be talking to the logic and telling the sign, when is the bus arriving, based on real-time information, and maybe there's some other service alerts there. So it's all very powerful. It's all stuff that's being applied in many different ways. What's I think kind of interesting is what's happening beyond the way we've thought of ITS, and kind of feels strange to talk about traditional technology given how new it felt 5 or 10 years ago. But that's kind of the old way of thinking, of just thinking about what we can do as one agency and doing one application like that. What's happening is there's more happening outside of the transportation space, outside of the public domain, and through new partnerships that's impacting the consumer world. And the consumer world is driving a lot of interesting innovation that's affecting public policy on transportation. So, as I said earlier on, when you are a person who's used to interacting with information and ordering a book on Amazon while you're walking down the street, and having real-time information on whether there's a movie ticket available, a lot of that extends to your expectations for the transportation system. And as things are more tied together in the digital world, there's more of an expectation that the transportation system is also tied together. So people tend to care less or have less tolerance for the fact this is a county road, this is a city road, this is a state highway, that this is the road, that this is transit. People want to make more kind of integrated choices, and technology is allowing them to do that. It's training people to think in ways that disregard these kind of jurisdictional boundaries. People want real-time information. Here's an example from just doing a Google search. If you pull up your phone and say, I want to go from Boise State to the Capitol, bam, there you go. It can tell you exactly how to get there on a BRT bus. So people say, okay, well, I want to know that now. I want to know what my choices are. I want to look at that. I want to know when to flip from that to the walking thing to see if it's faster to walk, or maybe flip to the driving instructions to see if it's faster to drive. And I'm actually making choices that involve a lot of coordination across these different modes and institutions involved. And then I think what's been playing out is you're seeing a lot of willingness, especially among younger people, or the so-called digital natives who kind of grew up with the internet and grew up with all these technologies, is a willingness to really adopt these new tools and say, well, okay, that's great, well, that's useful to me, I'm going to use it, or at least I'll give it a try, and if something better comes along in 6 months, maybe I'll adopt that. So there's a tremendous amount of innovation happening in the transportation space. Lots of different applications for mobile devices, lots of different new startups trying to sell services. Here's an example. I talked about real-time information, but also real-time feedback. Again, people are getting trained that if I go to a restaurant, I might look up the recommendation on Urban Spoon or Yelp or one of these services. I go to the restaurant, if I have a terrible experience, I want to give it a 1-star rating and give some feedback. So here's an example, is Waze. You may have heard of it. It's a traveler information application, and it can kind of give you a map and tell you traffic patterns and give you data, but it also gives you a lot of sort of feedback things. You can say, well, I've seen a speed trap, or I want to report a traffic jam. So it's this kind of interactive experience with transportation, but it's going through this new company that didn't even exist 5 years ago, and it's not having to call 911 or having to have a police responder be involved. And so it's very interesting dynamic going on of how these things so these little communities of transportation information are forming, and how the information is going back and forth. I should say, when you look at Waze, or you look at Google, or you look at INRIX or some of these services, one thing a lot of people don't appreciate is that a lot of the data that is going into these systems is actually generated through public agency systems. So it's traffic count stations that ITE may have on the freeway or others. Often it's combined with other sources of data. Maybe it's cell phones, probes, and people tracking cell phones on the roads to figure out travel speeds. But it's some interesting fusion of public and private data and services coming together to make these things work. This is kind of a pure feedback thing. I apologize, it's a little hard to see that picture's a little fuzzy. This is an application that the city of Portland developed for citizen reporting. They call it PDX Reporter. And basically what it is if you're walking around the city and you see a pothole or there's a graffiti tag on your stop sign, you basically go to it, you can take a picture, take your GPS report, and you kind of scroll and tell somebody what the problem is, and theoretically these get resolved. So again, it's kind of instant reporting and sort of an expectation that it's going to be taken care of. See a lot of that in transportation. And of course, there's things we don't even know how some of these things are going to affect us yet. It's pretty wide open. So this is, of course, the Google Glass. I've never used it. I don't know if anyone has ever had the chance to use it, but some people find it nauseating and disorienting, and they want to throw up when they put the glasses on. But other people say this is absolutely fascinating. This is really going to revolutionize how we think of information. And it's so second nature now to pull out your phone and look for directions or look up something on the internet or check your email, and this is going to make it all the more so. And so, people are coming up with these applications that say, okay, well, if I'm wearing my Google glasses and I'm walking into the subway and the subway service is suspended, I get a little notice. Maybe I get driving directions, or maybe I get, it's hard to see there, but the departure times of the trains. And so it's just one of these other consumer devices that's becoming a new interface for the public with the transportation system. And you have to think about if our interest is in providing information, helping people make informed decisions, and not get caught in traffic jams, how are we going to relate to all these devices to make this all work? So another thing you've probably heard about is how technology is creating sharing economy in transportation. So everything's kind of for rent. You can rent your parking spot in a big city if you live near the stadium and want to make a quick $10. You can rent your couch on Airbnb to a stranger and they can sleep on it overnight. Well, there's lots of things in transportation that are out there. Zipcar is one of the first and most prominent ones. I believe they've got a few cars over at Boise State, and they're getting into airports now. They're really expanding, and it's basically car rental, but by the hour. And you make the reservation on a website. You say, I want the car from 3 in the afternoon to 7 p.m. and I'm going to go and maybe do some errands or go out, take a trip into the country, and then I bring the car back, and it's all paid for through the internet. It's made much more flexible sharing of infrastructure, and it's become very compatible with the certain segment of the population who wants to live in a more urban area, who maybe is more open-minded about sharing because they don't want those fixed costs of owning a car and paying for insurance and doing all those sorts of things. So kind of where it gets interesting is that might have been a very conventional transit patron because they didn't own a car. Now they have a car choice, and it might really change our thinking about how we even understand how people make decisions about how to travel and which mode. Uber's another one. I don't know if anybody's heard of Uber. It's largely in the bigger cities, but the basic idea, if you wanted to get a ride with a black car driver in New York who was waiting for, take his ride back to Connecticut, you used to go up to them and say, hey, we want to get across town, there's $20, so you do it, and all your friends pile in the car, and he takes you $20 and he gets a little cash on the side. What Uber's all about is saying, if I got drivers out there and somebody else who wants a ride, this service will match you to that driver, and you book a trip, and it, kind of tells you where to meet, sends messages to the driver, and tells you how much it costs. And then, of course, being the new age here, you can rate your driver and how courteous they were and all that. And I'm sure that affects how they can price and how they get trips and all that sort of stuff. So just a totally different model. It's got a lot of taxi companies and things really upset because they feel it's undermining their medallions and the whole model and the pricing structure and regulation. So, cities are dealing with this. What do we do about this company that didn't exist 3 years ago? And bike sharing, another example. I believe it's been talked about in the Boise area, but it's in Washington, D.C. and a lot of other places. Kind of started in Europe. And again, made possible by the fact that it's easy to have accounts and electronic payments and things, and again provides a lot of flexibility of using urban infrastructure. So let's talk a little more about payments. So, a lot of transportation services cost some money, or they have some value, and people are trying to find ways to price. One of the classic conversations in transportation is, should I be charging money to travel in rush hour because there's a higher social cost, and maybe I want to just give people an incentive to take the bus or to travel at a different time. And of course, there's been a lot going on here in the past several years. London, Singapore, some cities have experimented with the central zone charging, where what's happening here is if you cross this little boundary where these C's are painted on the pavement, you get charged a rate. It's pretty high. It's 10 pounds or something, not an insignificant amount for a day trip into central London. And there's some cameras, and they record your plate number and make sure you pay and settle up the account. And it's of course to dissuade people from driving into central London and causing congestion. More typical examples in the United States involve electronic toll collection for toll roads. So the closest ones here in the Seattle area, where there's the toll bridges and there's electronic toll transponders that WashDOT maintains, and a lot of the East Coast turnpikes and things use electronic payment as well. Well, the next step beyond that is to price your infrastructure flexibly. And so, this example, which is from Minneapolis, is taking this express lane, and instead of having a high occupancy vehicle lane or HOV lane, which is the old way of thinking, saying, let's make a special fast lane for a car that's got 2 passengers or 3 passengers, you can actually buy your way into this lane. So depending on how bad traffic is, that price is higher or lower, and I can say, it's worth $10 to me, or $2 or whatever the price is to bypass traffic and get to the office on time. So people debate the pros and cons of whether that's fair and equitable and the best use of transportation, but the reality is it makes money, and it's happening in a lot of places. And it's at least providing a choice for a price in the transportation system. And you can see that the bus here is also taking advantage of it, which is good for transit patrons. Electronic payment, going back to transit. I think we're getting near the point where you won't have to have cash on a bus anymore. We're not quite there yet, but this example is from a mobile fare, mobile payment application that TriMet rolled out last year. And basically what it is you have an app that you load on your phone, and you can purchase tickets right on the spot. So you don't have to find a vending machine or find a Safeway where you can buy book of tickets, or have the exact $1.50 in your pocket to pay the cash fare. You say, I want to activate one of these tickets, and maybe I want an adult day pass or an adult 2-hour ticket. And I've set up an account, it's tied to my credit card and all that. And so when I click use, it turns into a little ticket on the screen. It's got security features like barcodes and moving pictures and unique IDs that are really hard to replicate. And if you buy a 2-hour ticket, it starts counting down from 2 hours to 0. And if you have to get on the bus and show it to a driver or show it to a fare inspector, you just use your phone. It's proving to be very popular, and agencies like it because it costs a lot less money to do this than it does to process cash or than it does to maintain ticket machines. And again, for a certain segment of the population that's very attuned to these sorts of things and looks for every opportunity to use a technology application, it's been very well received, and it's being done in other agencies around the country as well. These pictures are pretty bad, I'm sorry, but this is another thing going on over in Oregon, and there's also some pilots in Washington, Nevada, a couple other places for called road user charging. So the problem you might have heard about in the news with our federal transportation funding streams is that they're largely based on the federal gas tax, which is a certain fixed number of cents you pay per gallon. And the problem is, like the minimum wage, like a lot of other things where you're increasing the price, it's really hard politically to push those things through. And it's not indexed to inflation. So if it was set at 19 cents 20 years ago and no one's had the political will to change it, it's still 19 cents. It doesn't change for inflation. And so as that purchasing power of the money's been going down, as our transportation needs have been getting greater, and as fuel efficiency has been going down, it's been harder to sustain a model where we fund transportation improvements with a gas tax. And forget about electric cars and hybrids and all kinds of other things that essentially aren't paying any. So Oregon and a couple other states have been trying a pilot where there's a device in your car And this is the little diagnostic port that most cars built in the last 20 years have. And you put a little thing in here, and basically it's got a GPS, and it's got a modem in it. And so it's communicating with some back-end system and saying, okay, calculate how many miles, just for a test, it would probably really look like this, but what it's saying is, here's the mileage you drove in rush hour, so if I wanted to, again, charge a premium to drive in congestion, I could do that. Here's what I drove in-state, where presumably I'm not paying a gas tax as a participant in this pilot. Here's mileage I drove outside of Oregon, where presumably I've paid gas tax to Idaho or Washington or California. If I was out of range or can't figure it out, it does that. Basically what it is it's saying for every mile you drive, you're charged X cents to use the road system. It's a mileage-based way of paying for the road tax. Now there's all kinds of complications with this. And, of course there's the privacy concerns of somebody tracking me, and especially is the government tracking me. And so the people are working through options. What if there's a flat rate? What if it's just based on odometer? In Oregon, eastern Oregon here, you've got large tracts of private land, so how do you deal with private roads and all those sorts of things? But people are working that out because we need a new model of funding. So that's kind of a brave new world. Same thing's happening with auto insurance. This is a company called Metromile. They're set up in Oregon, Washington, California right now, and are looking at other states. And kind of like Zipcar and the bike share and Uber, it's a little more geared towards urban area residents. And the basic philosophy is if I own a car, instead of paying so many hundreds of dollars for insurance every month, what I want to do is pay for every mile I drive. And again, it's kind of lining up incentives for people who either have choices not to drive or maybe who don't drive very much. And so you can say, hey, I use my car on the weekends. I don't really drive in rush hours and all this sort of stuff. So I should, I feel I should be charged a lower rate for my insurance. So if you work with this company, and they're kind of an interesting group, I had a chance to meet a number of them. They send you this box to sign up, and you get the similar little plug-in that goes in your car, uses the standard port, a little welcome kit there. And then you can go to a website and manage all these sort of statistics about your trip. And this is another thing that's happening at the personal level, to kind of hyper-analyze everything you do in transportation. I mean, same thing with cell phone bills, right? There's all this information, there's all this ability to plot and graph and map everything you're doing. And so one of Metromile's other pitches is saying, we can offer all these services in addition to selling you auto insurance to tell you about your commute. When you go this way, it's usually faster. When you go that way, it's not. If you try to keep your mileage under a certain level because maybe you're eco-minded, we'll show you how you're doing on a graph. So it's pretty interesting, but again, bypassing completely the conventional models of auto insurance. So that's a bunch on sharing and new payment models. But there's also a lot going on inside the transportation agencies just to make them more efficient. And like everything, like office environments, like what you're doing in your home, there's just again profound implications of the digital revolution. So you're not likely to see it, but if you look at snowplows in Idaho and a lot of other places, they've actually become very sophisticated, kind of like that bus that's got the GPS and all these different features on it to manage transit service. Snowplows are now coming equipped with very sophisticated sensors to understand the road temperature, pavements, and the dew points and all the conditions, to manage how much de-icing material is put down, and to understand conditions generally on the roadway, to know where the plows are and where they've been and where they've last plowed, and which roads haven't seen a plow come through in a while. And it's making the winter maintenance activities more efficient. Here's another kind of just an interesting, obscure little example. This is out of Birmingham, England, and it's a bus stop. And what it is they come up with a way to use little screens made out of basically e-paper kind of display that you use on an Amazon Kindle, like a book reader. Very low power, relatively inexpensive. And it made the business case to say, instead of us printing posters, the way we always have, and then sending people out and slipping posters in those things, and then 3 months later, going and doing the same thing over with a new schedule, we can just do this. We'll send through a modem the new data, and you get the new schedule. If there's a special event going on or a disruption in service, we can instantly send that out. So kind of interesting. It's very just efficiency-driven way of looking at that particular problem. And data analytics is, I showed some examples of how Metro Mile and some of these other things are presenting consumer data. Well, there's a lot of potential, I think a lot of untapped potential for using data to analyze the transportation system. And we are just at the forefront of this. I think it's going to be a really exciting area in the next 10 years or so. So basically what this is remember all those ITS devices and all those cars running around with GPS? Well, they're creating just terabytes of data, okay? You can piece that together and start to ask some really interesting questions if you're involved in planning or if you're involved in looking at transportation performance or you're trying to make investment decisions about new roadways. So, for example, just where all these sensors coming from, well, this is a graphic from a company, Inrix, one of the providers of public and private data that is kind of combined and fused and used for the general public travel time applications as well as for agency data analysis. And they kind of make the point, well, we bring in all kinds of information from road sensors and traffic cameras and commercial vehicle fleets and smartphones, and we sort of mash all this together and we use that to identify where incidents are happening and compile all this data. And that's great in real time. If you're looking at Google Maps and you search for it and you click traffic, there's a service like this that's behind that. It's pushing out the information and telling you where the delays are. But if you store all that information and say, well, what's happened over the past year? I mean, how many crashes have been here? How much delay's been in that area? How is this road used compared to maybe one over here? And really trying to understand the transportation. There's a lot of new data to mine. And we're just really at the point in Treasure Valley and in most places of thinking about how to build a data architecture to bring these different sources together from different agencies, different providers to be able to take advantage of that capability. And it can really change how we think about measuring transportation performance and looking at new solutions to transportation issues. This is something kind of fun. This is a project that involved IBM and I think a couple of the cell phone providers. And they looked at a city in West Africa and said, we're just going to watch people go around the city. Millions of people and traveling everywhere. And just track their GPS cell phone signal. That's just going out there all the time. And they said, well, based on the patterns we see in these trillions of bits of data, we can actually understand better ways to design the bus routes that are more efficient. And I think their initial estimate was make it about 10% more efficient because maybe we design routes that don't involve a transfer, or they're more direct to where people want to go. So that's pretty powerful. It's very different from going out and doing surveys or following the historic route that used to be a streetcar 100 years ago. And again, I think we're just getting to the point where we're understanding how to do this. And then safety and security, just a couple of examples. There's a lot of things going on. I won't talk a whole lot about connected vehicles, but there are major pushes with the auto manufacturers to bring technology into the automobile and allow automobiles to communicate with each other, to communicate with infrastructure. So there's been work, there's a program through the federal government, Connected Vehicle Initiative, and Ford and GM and all these guys have a test track in Michigan, and they're trying to build networks to help avoid collisions. And probably ultimately this will morph into that Google car. It'll be the sensing that allows the car to drive itself. But people have looked at all kinds of applications. If a car is running a red light, the other direction won't turn green, and if you're about to sideswipe a car, then alarms go off, or it swerves. There's all sorts of things, a little crazy. And even in materials, it's not all about ones and zeros and information. This is from a demo on the bottom here. This is from a demo in the Netherlands, a road with basically glow-in-the-dark pavement markings. And this line on the bottom here is basically just glow-in-the-dark paint, and it's kind of providing better vision on this road, and especially when you don't have traffic lights. And this thing is actually temperature sensitive, and somebody's imagined this thing where you use this temperature sensitive paint to tell you when the spot is icy. It's kind of an interesting model. The one on the top is actually a solar road, so the roads are solar panels, and as a side benefit, they kind of glow. And this one's always made me chuckle because I have no idea why it's saying slow. Is that like US 50 loneliest road in America? Like drive for an hour with your eyes closed. But anyway, it just shows you where your thinking is. So I was like, what do we make of all that? Another grainy picture. This is from an old camera. But video analytics is an interesting world in safety and security. It's also being used in traffic management. Back at the ACHD shop this morning, I saw some examples of their new video detection where the camera is looking at the cars in the intersection and kind of detecting who's waiting for the light to turn and using that to drive the signal logic. What this one is basically tracking people in a parking lot. And people have looked at these in airports and train stations to try to find abandoned packages or somebody who's fallen over. People use them in parking applications to see if any of these walking patterns don't really make sense for what you'd expect. Somebody's going from door to door of a car, seeing if any are unlocked. That's pretty suspicious. And you can use that kind of video analytics to trigger an alarm. So maybe there is somebody watching, 500 of these cameras and responding. But if something like this that's unusual is detected, you can alert that person to actually do something about it. So all these things are going on, and there's lots of other examples. I'm sure you've all seen things, and we could talk for a long time about it. But seeing what's coming down the road on some of these it's a challenging business. You see the potential of it, but often it's hard to implement, and we all know we can be taken by surprise of what comes out of the fog because none of us have the foresight to see it. But I think it is pretty clear if you look at what most folks are saying. We're going to continue to see these new business models, these disruptive technologies, and they're going to involve people who haven't traditionally been involved in transportation infrastructure or delivering transportation services. And I think we've got to be really open-minded if we want to make the most of what these things have to offer. And we have to be anticipating that something's going to come along, and it's going to seem great, or maybe it's going to seem great on the surface, and we have to have some way of some grounding, some bearing to evaluate that and say, well, is that relevant to the needs of the Treasure Valley, or is that kind of a bright, shiny object, and we maybe ought to be a little more cautious about it. Certainly smart infrastructure, and that's cars talking to traffic lights, that's cars talking to each other, that's embedded sensors on people and freight. We haven't even talked about freight. There's a whole different revolution going on there. All these things are producing information. They're telling us where they are. They're telling us how they're interacting. They're helping us manage the network through very powerful analytics and computing. Information, I think, is going to continue to be very personalized. And what you're going to find is that expectations are only going to increase, that whether it's Google Glasses or phone or your car or something we haven't thought of yet, that there's going to be an expectation that if you're giving me information on the transportation network or asking me to pay for something or make choices, I'm going to want to do that in a very personalized way. And we have to think about how we interact with these new players and how we have data standards that allow us to continue to connect with these new services. The automation and assistive technologies, if you got a rear view camera in your car, it's sort of the feature's already here. The Google car will only take that to the next level. And then data analytics, as I said, is going to be, I think, very, very powerful for folks involved kind of in roles like I am, where we're trying to understand and make recommendations on transportation. It's going to really change things. So I'm going to take a break there. Any thoughts or questions on kind of what's happening? It's a broad range of stuff. There's so many things going on. It's a really big topic. What I wanted to focus on for the next part is, oh yeah, got a question.
On the Wi-Fi and all the stuff going down the expressways and the corridors, what technology is going into the corridor itself for the future? I didn't hear you hit that. Are they planning for that as well?
For like a vehicle talking to
I'm just talking about broadband, the connectivity, that if you're putting out new roadways, have we got that solved?
Anticipating? Well, that's an interesting question. That's a very very hot topic in the Treasure Valley now and in a lot of other places. So the saying, that a lot of the applications require this communications network. And just as a society, as we build more intelligent and interconnected schools and healthcare, there's a lot of demand for those networks. The real question now is how can we be smart and efficient about deploying that infrastructure? And there were conversations literally this week among some of the agencies involved in transportation and emergency services, education, about how to make a smarter integrated network. And as far as expanding the network when you build new roads or expand roads, there's certainly advocates for having standards where we say if we're putting in a new road or doing a widening, we should also be putting in the conduit and the fiber optic cable if that's what we need. And when we think about whether we need a fiber optic cable, we should think not only about what the transportation agencies need, we should think about school districts, libraries, fire stations, maybe even private providers, and try to get the best win-win for everybody about deploying that infrastructure. So, a lot of things are going wireless, and some of those really forward-looking technologies, like the vehicle-to-vehicle communications, will be through the air. There's still a tremendous need for fiber optics, and it's going to be with us for a very long time. Good question. Yes, sir.
So you talk a lot about how we're becoming more interconnected, things like that. When does technology when do we have too much technology in transportation? When do we hit that mark? When we have too much?
Yeah. Well, it's a very subjective question. I'll talk for a minute what some of the drivers are for looking at technology, and I think arguably we're in a period where we're going to continue to see more and more. Part of that is this societal impact, the digital revolution, and part of it is looking at what technology can do to meet transportation needs in a cost-effective way. Because often the alternatives to investing in this technology are things that cost 10 or 100 times more. Yeah, there are a lot of challenges, and the growing pains of some of these technologies. I mentioned if somebody's tracking my car to see how many miles I go, or I've got electronic payment, people are concerned about privacy. It's very, very understandable. We're dealing with that in so many other aspects of Facebook and Google and Amazon. All these people who have our personal information, and it gets stolen, and these bad things happen. You can look at just all kinds of negative things that could arise. But I think on balance, the momentum is towards having more of these because the applications, because the benefits are outweighing the cons.
Question on in terms of the seamlessness is we're seeing some of that in the system. We really are not seeing that in the equipment. As one of my engineers would always say, he says, every time I get a new device, it has to work with all my old devices, and they never do. There's all these little firms, a couple engineers split off, start making a widget that does this cool thing, and these guys are competing, they're selling it over here. It's really, one thing, it's really hard in the public sector to get the one that is the most reliable, to get through the public bidding process and all that, to get one that's reliable, and that company's still functioning in 2 years, And it's just it's kind of a headache from that standpoint. And then it doesn't work. The one you were just talking about, we had a new camera that looks all 4 directions, sees all the cars in all the lanes, can actually hand us print out traffic counts of all the lanes. But we're sending people out in the field to do by hand. We can print it out by hour or whatever we want. It just, and yet at the same time, that's totally inconsistent with the cameras we're putting in on the other part of town with new adaptive signal technology. It doesn't work that way. It's one or the other, and I just see this collision course of these devices.
Well, I can appreciate that. It's very frustrating, and I think, historically, it's almost been a way of, it's better to sell a proprietary system, and I get you buying my thing, and it doesn't work with my competitors, then you're always buying my thing. But I think what's happening is there are forces out there that are counteracting that. Part of it is going to be the demand for interconnected information and data. People saying, look, I need to know the traffic information, the flow information across my network. And I'm not going to buy your product if you can't give me the open thing, and kind of use peer pressure and shame to hopefully get that done. One of the things that's been really interesting to watch is in the kind of late 90s, early 2000s, there were very strong pushes, mostly by the federal government through developing the NTC-IBI standards, these kind of national standards for transportation communications, to say this is the way a traffic signal controller should talk to a central traffic management system, or this is the way an electronic sign should talk to its central system. And kind of got some half-hearted, well, yeah, we're compliant with those standards, but you test them, they didn't always work, or sort of anything. But lo and behold, Google comes along in a slightly different space, and they say, you know what, we want to get transit data because we have that vision of building transit information, transit instructions into our map. So if you search, how do I go from Boise State to the capital, we want to tell you about transit. And so what they said is basically, hey, transit world, we've created a standard. It's called GTFS. And if you want your transit information to be on Google, and you want people to be able to search in your city and find it, you publish the information to us through the GTFS standard. And lo and behold, it happened. Because part of it is, boy, I saw this great thing in Chicago. Why can't we do that? And, it's kind of everybody wants it because it's Google. And they pushed it further, and they've adopted a real-time variant of that standard that actually lets you pull in real-time status. So not only can I tell you how to get from Boise State to the capital, I can tell you if your bus is late. I can tell you right on your phone, and then you might say, oh, it's 7 minutes late, I'll just walk, I can be there. So, they kind of use their market power to do that, and so been very effective. And I can only hope as we look at some of these emerging applications where it really does require us to think about merging different data sets, that we find more of those kind of market forces forcing open data. Another thing you see is using that GTFS standard, some other things is a lot of transit agencies and DOTs will publish their information to a developer portal. And basically, if you go to the website of TriMet, I showed you one of TriMet's signs that they own. Well, you can go to a website and basically, enter some code into your app and access their real-time feeds for transit schedules. So if you want to build any kind of device application, and people have done crazy things. You point your phone at a bus stop and it tells you when the bus is coming there, and it's just mind-boggling the innovation going on. You have reliable data, and the reason they came to that conclusion is this is a different perspective from what you're describing, but the agency said, we're finding people are stealing our data off of old website cached versions, and the schedule's wrong. So people are going to do this and innovate. We just want to make sure at least they have the right data. It'll be more useful for our customers. And there's been an explosion of innovation going on that's supported by that open standard. And so if we can replicate that attitude with certain product vendors and in other spaces, I think there'll be, again, an explosion of innovation going on, how to use that data. Okay.
So it seems like a lot of these advancements have been kind of pushed through by private companies, it seems. So would you say that it's the obligation of the private sector or the government to continue this revolution in transportation technology?
I think right now they kind of need each other. I think that the private sector, just general digital revolution. I mean, there's a lot of innovation, there's a lot of money, there's a lot of development talent going on, and it's pushing some things in the public sector. But at the same time, the public sector, and I'll talk in a minute, is looking for new innovative solutions, and there are also very innovative and creative people involved in transportation. So there's kind of a meeting in the middle of saying, you know what, we're thinking about these new applications, these new products, this new computing power, and we're trying to decide how that relates to transportation policy. We're trying to find how that's going to make our signals work better. And we're trying to figure out how to use video analytics to make customers in a parking garage or a train station safer. So I think it's really meeting in the middle. But it is a different way of thinking because people who thought of the old way, we're the experts. We build roads. It's physical infrastructure. It's challenging and it requires a lot of new partnerships.
Kind of along that line, I was just at a conference in March where the project manager for the Google driverless car was presenting, and basically what
You have glasses?
Yeah, what they do, they memorize the road. Basically, they input everything on the road, and they can drive from San Jose up to Golden Gate Park and through various roads and so forth. But they need to know what's there, and they said, what we need from you as agencies is your construction information. And they just don't need general information, they wanna know where every cone is, you know, I mean, they gotta tell precise information to this driverless car as to what that road situation is. He says, we don't have a clue yet on snow and how to deal with
Yeah.
that, so, I mean, there are ways from, you know, just taking off in Idaho and going anywhere type of thing, whereas the connected vehicle is the industry effort coming together with government, and that's more talking to each car, to each other, and to the system itself, and not the independent thing. So neither of them has it all together, really. It is an
Yeah.
interdependent thing, it seems.
Yeah, and it'll be interesting with all of that vehicle space to see how the standards and things come out, because we can all sit in the room and say, you know, we're looking forward 20 years of technology planning in the Treasure Valley. We know there's going to be some sort of connected vehicle. We ought to plan our infrastructure. But it's really hard right now because there's no standards, we don't know the applications, we don't know the performance needs of the technology. So, you know, in a way, we're kind of in wait and see mode on that, but it also speaks to the mentality we have to have is, you know, when that comes along, when there are things we need to try, when we need to adopt standards, when we need to, you know, put in the communications backbones to support that, we've got to be doing that and just nimble and you know, kind of ready to figure these things out as they come. That's the tsunami wave, kind of, we got to figure out how to deal with that. All right, well, so I'm going to talk a little bit, what does this mean for the Treasure Valley? And, you know, I think what I'm really saying is, we've got this technology, how can we sort of make the most of it and apply it to the transportation needs of the valley? So the way I think of a lot of things, and I think a lot of people think about technology, is the following conundrum, okay? So there's a lot of people either moving in or, you know, being born in the Treasure Valley and the population's growing. The transportation network is not growing as fast. Transportation funding is not growing as fast. The environmental and financial implications of building infrastructure at the same rate we did in the real eras of road expansion is pretty challenging, maybe unpalatable to the community. So how do we deal with that? You know, we're getting a network that's essentially more constrained. There's more vehicles using it. There's less tolerance for things going wrong. Transportation folks in the room may have seen a chart like this one day. This is a federal highway chart, and what it's really showing is the green line up here. This is lane miles of roads, and this is total public road miles. So this takes into account, you know, how many lanes a road has. Basically the same trend. You can see it's pretty flat, saying, you know, between 1980 and 2010, you know, there's been, you know, I don't know, maybe 10% growth in the total lane miles in the network. Well, look at vehicle miles here. You know, it started out in 1980, it was down around maybe 16 trillion. It's gone up to 30, so it's almost double. The amount that people are traveling is about double, while the amount of actual road infrastructure has decreased at a less rapid rate. So again, we're filling up our space, and we're not making space as fast as we had. Another kind of famous federal highway diagram here, causes of congestion. So people said, all right, congestion's a problem. Everybody cares about congestion. The public cares. Elected officials care about congestion. What's actually causing it? And it's pretty illuminating when people started to really look into this and say, okay, well, you know, there are bottlenecks in the system. A 3-lane road goes to 1 lane, or, you know, there's a traffic light. It's a bottleneck. The road doesn't have as much capacity. And that's about 40% of this pie. But if you look at just about everything else, special events, poor signal timing, work zones, bad weather, and traffic incidents, 60% of the pie, that's basically stuff that's not happening all the time. That's, you know, maybe you can predict where some of these events are. Maybe that's around the Idaho Center or the Boise State Stadium on certain dates. But, you know, bad weather hits, bad weather hits. There's only so much you can do about it. Work zones are a fact of life. You know, traffic incidents are pretty unpredictable. So even the whole idea that you could build capacity in the transportation system to address these is a little misguided. You know, where do you build the extra capacity? You don't know where the wreck is. You don't, you know, listen, the snowstorm's going to knock it all out. So what it suggested is that there's a set of transportation strategies that really should be integral to the Treasure Valley's transportation approach that involves managing these kinds of causes of congestion and managing the network. So, you know, I remember I showed you that incident management slide. When a traffic incident happens, we can't prevent the traffic incident, but we can respond to it as quickly as we can clear it off the road, we can give people information so they can make other choices. Those are the kinds of responses that are actually going to eat away at some of this congestion. So one of the key opportunities in the Valley is saying, all right, if we're using technology, how can we use it to maximize the performance of the transportation system? And we say transportation system, we're talking the multimodal transportation system, thinking of the freeways, the arterials. You can use information to make this all work better, whether it's someone looking at the bus schedule and managing that in the back end, or whether it's a traveler looking at information on their phone, making the choice about when, where, how, or whether to travel that day. That's some of the opportunity. So to the fine folks here at Compass, we've recently updated a vision for operating the transportation system in the Treasure Valley. It's focused on operations, and technology is a part of that, but there's a lot more that goes into operating. It's having people and resources, it's having plans, policies, funding to make it all happen. Basically, the position is that part of what we're going to do to manage the transportation system and to meet future growth needs of the region is to make sure we're actively managing the transportation system. We're investing in technologies, and we're going to use the technology in combination with a collaborative, cooperative approach to get the most out of the transportation system we have. And what it's going to let us do is be addressing our transportation needs in a more cost-effective way, so that when we do need to widen the road, we do need to make a big capital investment, we're able to do that along with technology and get a more tailored and effective approach. So this little map, here's the Treasure Valley, Caldwell here, and Boise down here. Some of the thinking that's gone into it, the regional planning is, well, where are the corridors in our region that are in need of management? And it's a lot of the region, a lot of the major corridors. So the colors correspond to kind of the darkest orange color here, the most urgent needs, and then kind of medium-term needs, and the blue roads, which you can see are kind of on the fringes, are sort of emerging areas, places that are seeing growth. They're going from a rural, farm-to-market kind of road to connecting subdivisions and office parks and things like that. And the idea behind this thinking was that we are identifying opportunities to deploy technology, or we have a hotspot of congestion somewhere in this map. We've got a plan that says we know these areas are important to manage. We've got ideas for technology, and we've got groups working together to make sure that the partnerships we're forming can take advantage of the technology. So this speaks to the second opportunity, which is really using the low-cost technology solutions when you can. Maybe to defer a big investment in a new interchange or a road widening, or maybe possibly even to eliminate it. Or possibly when you have no alternative. Maybe you've got a roadway that's hemmed in. If you widen the road, you're taking houses and stores or a park, and maybe that's just not what you want to do, even if you could afford it. So there's choices to be made when you're looking at transportation investment. Say, well, there's the old way, which always was looking at demand and trying to expand capacity. And capacity that's really inflexible, that doesn't respond to all those operational challenges. Or maybe there's some technology, we say, look, if we just manage our signals better and had some technology and making sure they're talking and being more responsive to the changing traffic conditions, maybe we don't need that extra lane. Maybe we could defer that extra lane 10 years. Or maybe it's going to take us 10 years to fund and permit that project, and at least the signal upgrade gives us something that we can do in the next 2, 3, 5 years. The other opportunity is making sure that we're informing travelers the best we can to make the informed travel decisions. And I kind of said it earlier, but I think from the public agency point of view, the real interest and the public interest is that people have the best information at their fingertips, however they want to get it. So if people want to go to just drive down the road and they see on the ITD sign that there's an accident, or they want to go to Google, or their car is speaking to them, or their refrigerator is telling them about a toaster. Well, if we can get the quality data to that device, or to that service, and get that information out, then everybody's going to be better off. Because that's one less car sitting in traffic. It's one less person stranded in a snowstorm. It's one less person who's missed their bus and is late to work. And so a challenge is building the partnerships and interfaces with private partners, merging information from agencies that manage different parts of the transportation system to make sure people are getting the big picture. And there's work going on in this area locally. There's lots of things going on around the country. But I think from here on out, it's going to be a very consumer-driven world, and that's just a fact of life. And there's a lot of opportunity because, if we can just create those interfaces, a lot of the work's being done on our behalf by people who are making these innovative products. Next opportunity is using the data infrastructure to transform planning and performance measurement. So, every day I kind of come across another tool that's about visualizing complex data sets or looking at networks in new ways. And these are things for the people who plan transportation day in and day out and give us a lot more insight into what's going on. From a policy perspective, folks here at Compass and many of the other public agencies in the Valley, and also there's initiatives with the federal government, are pushing for a more performance-based approach to transportation, really what's the bang for the buck we're getting out of our system. How can we measure the reliability of our system and understanding how well it's performing when all these kind of random events are happening? So just for an example, today, Mary Ann, her colleagues upstairs, work on monitoring the congestion hotspots in the region. It's called a congestion management process. It's a federal mandate of the region. And what it is really geared towards doing is finding these kind of red areas where there's a lot of delay and maybe something needs to be done. And the goal of the program is to highlight places where you can focus on those acute congestion problems and maybe target investment there. It's a very nice analytical tool to guide how you spend your dollars. Well, the thing is, the way this is done today and the way it's done in most places for years is, you do some travel time surveys, you send somebody out in a car with a GPS device or a stopwatch, and a couple times a year you get a couple samples. And so you miss the information of when those bad days happen. You don't see the little bumps, the day it took twice as long as normal to have a commute. So what's being done now is agencies in the Valley are deploying Bluetooth sensors that, again, are looking at signals off of cellular phones and collecting basically the travel times by looking at how long it takes an individual signal to go along these routes. And that's data collection you can do all the time. And you can even merge it with the private companies who are also looking at cell phone data, or who are looking at FedEx trucks and other sources. And you get a much fuller picture of saying, okay, well, it's usually 17 minutes to do this drive, but some of the time it takes you 30 minutes because this road's impacted by crashes on I-84. And so you start to understand reliability, and that's always been a really hard factor to capture. But that's actually where a lot of the payoff is for technology, and it's where a lot of the frustration of the public comes from. So, what would this look like? This is an example from the Atlanta Regional Council, and you're looking at the kind of belt of freeways around Atlanta and kind of the radial ones there. And what they're showing you in this graph is one of the early examples of trying to capture travel time reliability by capturing travel time data all the time. And so what this is call it planning time index. Okay, it takes a minute to think about what this is, but basically it says if I'm driving the peak of the afternoon, rush hour in the afternoon, how much longer does it take me compared to when there's nobody on the road at all? I'm just going the speed limit at 3 in the morning. And what it points out is, I can look at this section of I-75 and say, well, a lot of the times it takes me 2 or almost 3 times as long. And so if I really want to plan to not be late for work, say 95% of the time, instead of maybe budgeting 10 minutes, I've got to budget 20 or 28 minutes. Because some of those days I'm going to be late if I don't. And other days I'm going to be super early, so I'm wasting time. And so it's capturing this idea that sometimes you've got to plan a lot longer. And that might be due to congestion every day just because there's a lot of travelers, but that also may be due to incidents. And so they're powerful new tools to understand performance. Another opportunity is making sure there is a kind of an infrastructure of relationships and plans and guiding principles to know when these sort of disruptive technologies come along, how the region's going to respond to them. So, when it is time for the connected vehicles to come in, or there is some new revolutionary technology coming around the corner, is that relevant to our needs? How can we make a business case? Can we convince ourselves and the public that that's a wise investment? And so we're fortunate that in the Valley there are working groups who deal with technology issues, who are working on operations. And I think it's the best defense you can have to the uncertainty of technology. And being clear, there's lots of interesting things out there. There's lots of ideas for sale, lots of commercial products, but being guided and saying, well, does this help us manage our incident? Does this help us inform travelers? Does this help us analyze performance? Does this help us do some other goal we've set out? And so that it's very important. A lot of the challenge of technology is about actually getting it incorporated into organizations, getting relationships built to take advantage of it. So, just on that note, what else is going to take? I think having a clear understanding of how you use technology is always a good idea. I think anytime you're looking at an application like this, even in your own house, what do I want this thing for? What am I going to do it for? Because there can be a lot of wrong turns when you're dealing with new technologies and people are feeling their way through it. And the best regions say, we're going to be very deliberate about this. Maybe we'll test it out a little bit. We'll try to make a business case. Is it saving us money? Is it getting us more benefit? We're getting the right product versus other competing products on the market. A lot of the opportunities in the Treasure Valley are regional in nature. We talked about making the freeways and the arterials work well together, handling commutes from Ada County to Canyon County. And so it's requiring thinking about operations in a much more regional way and thinking outside the jurisdictions of any one individual agency. And that takes a lot of work. It takes a lot of trust building. It takes a lot of planning effort. And that's really a foundation for making the technology work. Integrating technology into regional planning is something that's already happening. Compass is updating their long-range transportation plan, and it does talk about the value of operations and technology to meeting regional transportation needs. But it's always something you got to be out in front of folks and make sure they understand that you may not see the investment in the roadway, but if there's technology going into traffic signals and things that are taking 10% off the travel time, those are stories that need to be told, and often they're not real obvious. And sometimes people struggle to understand some of those investments and how powerful they can be. Embracing disruptive technology, business models that may involve change, may involve new roles, new partnerships, maybe throwing out some old thinking. And I think one of those, as Terry was saying earlier, is the idea that technology vendors maybe are a little proprietary in how they deal with things, and maybe we ought to have more open standards. We ought to embrace those kind of models and force that on partners, but also do that inside agencies and communicate that at a regional level. Got to be flexible. One of the things that's different about planning for technology versus the old days when you plan for roads is it's pretty easy to plan for roads 20, 30 years in advance. You kind of predict your population, and you got projects that take a long time to build anyway. Well, technology is pretty different. I mean, what we were talking about 5 years ago is not what we're talking about now, and it's not what we will be talking about in 5 years. So it demands being nimble and being open and willing to move. And that's kind of that's where it's really powerful. If you kind of have your guiding principles and your plans, and you know where you're coming from, and then you kind of also have the willingness to look at new technology and embrace them and to take some risks there. I think that's really how you take advantage of technology. And then the funding commitment. Often when you do technology, instead of putting a lot of money into infrastructure up front, you have an operating cost. It's, think of your cell phone. You buy the phone, but then there's the monthly plan. Or you do something with anything of operational. There's a cost of people. There's upgrading technologies along the lifespan. There's these things that are different from building a road. You build it, you maintain it, you plow it, and you restripe it, and those things. But there's no real investment for a long time once you build it. Technology is a little different, and again, it requires some understanding that that's a different model. And sometimes it's a struggle to find money and make the case that I need an extra person who knows the technology and keeps it running. That's the trade-off we make to use technology instead of building a road. So, if we do all this, I think the payoff is good. It's what we've been talking about all night. We're going to have a transportation system that has the most bang for the buck for what it is. It's going to be reliable, it's going to have good capacity, and it's going to help us meet our needs. We're going to put our dollars where they matter, partly because we're spending less through technology on certain things, and we're saving our scarce dollars for major investments where we really need them. I think also because we're really going to understand where our needs are, because we have data that helps us understand what's going on in the transportation network in a way we never did before. We'll understand through public decision making, how people making trip decisions, and let people make decisions that are very informed about how they travel, and kind of, if there are problems in the network, you inform people, they'll tend to spread themselves out. They'll tend to heal around the challenge. We'll improve safety, and part of that is it's incident response. It's snow plows, knowing where the icy spots are, but it's also all these emerging private sector technologies. And I think we'll just make a network where we're measuring it to a performance standard, and we're able to show how we're doing against that standard. Not only makes us more effective at delivering the service, I think it builds a lot of confidence in the public and saying, there are actually some metrics, or some hard metrics for how, am I getting a better transportation system now than I had yesterday? Are people doing a good job at that task of managing the infrastructure? So just a couple kind of concluding thoughts to go back to the basic principles. Keep in mind, technology is a part of transportation infrastructure. Never really was thought about. It's very much a part, and it makes everything we talked about tonight possible. The transportation infrastructure is also involving a lot of private sector players, as you saw some of the examples. There are new solutions that are being created, and the real challenge is finding the match to the need and the solution, and that involves a lot of people talking and discussing what's right for the valley. Technology helps us do things. Technology makes the Waze service or the Google Transit possible, but it's just a thing. It's just a widget, and you have to know what you want to do with it to make it effective. Some bad examples of technology implementation all over our economy. People often say, oh, if we buy that thing, we implement that product, do that system, everything's going to be fixed. But if the people don't change, if it's not done purposefully, it tends not to be the case. And again, that's a complicated challenge. And as we do the technology, the people, plans, processes, policies are all just as important to make the change that we want to see. And then, finally, technology uncertainty is certain. It's the world we live in. Go back to the wave. We're going to have the tsunami. We all know that. We've all experienced and lived through that. These changes. I think it's going to be no different for the foreseeable future. But we want to decide how we can use that to our advantage, and where there is an opportunity to look at new technologies, to see the possibilities and to make something happen, then at least we're not getting engulfed by those changes. We're using those changes and doing something positive for the valley. That's pretty much what I had to say. So thanks for coming. I appreciate you all listening and your questions, and happy to talk more.